So now we're going to design a function that operates on list of string. And remember what I said in the last video. We still don't have all the changes we need to the how to design function recipe to do this. So there's going to be a place in here where I'm going to make a lucky guess. And that lucky guess is going to turn out splendidly for me. And then in the next video, I'm going to come back and really explain away all those lucky guesses so that you can make them too. We're starting where we left off in the last video. We have a data definition for list of string, and that's the type that we're using to represent lists of Quidditch teams. But remember, there were three things about this data definition that I said I would talk more about later, and that'll be in the next video. One was this self-reference here at the top. One was the fact that I put in this funny call to fun4LOS here. And the last thing is I didn't say what template rule caused me to put that fun4LOS. Now if we go down a little farther in this starter file, there's a second problem. And the problem here is we want to know whether your list of favorite Quidditch teams includes UBC. So we're going to design a function that consumes list of string and produces true if the list includes UBC. So this is a how to design functions problem, so let's just get going. Signature first, it's going to consume a list of favorite Quidditch teams. So that's list of string, that's how we're representing that. And it's going to produce true if the list includes UBC, so that means it's going to produce a Boolean. And let's see, we'll say produce true if LOS, we'll call it, includes UBC. The stub is defined, let's say we'll call this function contains UBC, LOS, and we'll make the stub produce false. We'll say that that's the stub. Now let's do some examples. We can get some inspiration from the data examples that we have in the list of string data definition. So empty is definitely a list of strings, so let's try that. Let's say contains UBC of empty. We want to check expect of that. Well, let's see, does the empty list contain UBC? Well, no, it doesn't, so that's easy, that's false. Here's another one, check expect contains UBC of cons McGill empty. Well, no, UBC is not in there either. Let's make one that UBC is in. Check expect contains UBC cons UBC and empty. That's true. Let's make one that UBC is in, but not in the first position. So let's see, UBC is in that list, so that'll be true. So we'll run that, make sure those examples are well formed, and they are. Two are failing. Now let's see, let's go get the template. And we'll comment out the stub. We'll rename the template. Now it's time to code the body. So let's see, contains UBC if LOS is empty, that's this first case. Then intuition, the purpose, and this first example, all three tell me that the result in that case is false. Now what about this second case? So this is the case where, let's see, it's compound. This is the case where we have an actual cons. And this first of the cons will be a string. So that's a case like this, where we have McGill as the first element of the list. Or it's a case like this, where we have UBC as the first element of a list. So in that case, we would produce false. In that case, we would produce true. So let's see, it seems like, or it could be this case here where McGill is in the beginning of the list, but we need to keep looking. So it seems like we need an if. And there's the if. And it seems like what we want to know is the first thing in the list UBC? So if the first thing in the list is UBC, That's this case here, where the first thing in the list is UBC. If the first thing in the list is UBC, then in that case we should produce true. Now what do we need to do here? What do we need to do in this case? This is the case where the first thing in the list is not UBC. So that's a case like this one, where the first thing in the list is not UBC. And it's also a case like this one, where the first thing in the list is not UBC. In this case, UBC isn't anywhere in the list. But in this case, UBC is in the rest of the list. So it seems like what we need to do here is we've got the rest of the list. It seems like we need to go look in the rest of the list to see whether the rest of the list contains UBC. That way, in this case, when we go look in empty, there won't be UBC there, so we'll produce false. And in this case, when we go look in cons UBC empty, we'll find the UBC and produce true. So what we need right here, what we need fun for LOS to be, is we need fun for LOS to be a function that if we give it a list of strings, will tell us whether UBC is in that list. It would be nice to have such a function. Well, we do, or I should say we almost do. It says right here that there's a function that consumes list of string and produces a Boolean, and it produces true if the list includes UBC. And all of this says that the name of that function is contains UBC. So since there is a function that does that, it says right there, there is, I can just make this be contains UBC. And now I'm done writing that function. Let's run it. All 4 tests passed. Now you may find that surprising. A funny thing happened here, which is we wrote a function that used itself. This idea, which is called recursion, is deeply connected to the idea we saw in the last video, which was self-reference in the type comment. For now, I'm just going to leave this video as it is, say that we're done doing this function, and then in the next video I'll talk about why this all worked out.